Welcome to another explainer brought to you by Forge College. So, we've spent the last few lessons deep in theory, specifically mapping out how ERC 721 concepts translate to Metaplex, right? Well, today we are finally trading in our theoretical EVM blueprints for a hard hat. That's right, we are heading straight to the construction site to actually build these tokens on Solana's Devnet. Our goal today is to create SPL mints and a Metaplex collection on Devnet. So let's dive right in. Here is the master blueprint for our factory build today. We'll kick things off with a welcome to the Devnet, then we'll review our blueprint specs, assemble the actual SPL mint, scaffold our Metaplex metadata, hit our Devnet verification checkpoints, and finally, wrap up the entire build. All right, Section 1, welcome to the Devnet, groundbreaking on the Solana SVM. Now, like I mentioned, we've been meticulously mapping out our metadata practices and schemas. Now it is time to pour the concrete. But before we do anything on the main network, we're starting on Devnet. Think of Devnet as our completely safe, totally isolated testing playground. It's the place where the tokens are completely made up, and more importantly, where your mistakes literally do not cost you real money. You can test your EVM to SVM transition all day long here. If you accidentally blow up your digital factory, well, you just hit reset and try again without breaking the bank. It is the absolute perfect place to get our hands dirty. Moving on to Section 2, Blueprint Specs, Knowing Your Tools. So, before we fire up the command line, we absolutely need to review the heavy machinery we'll be operating today. First up is the SPL Mint. And here is where Solana is vastly different from Ethereum. On Ethereum, a token is basically a giant smart contract ledger that tracks everyone's balances in one massive list, right? Well, Solana separates the factory from the storage. The SPL Mint is strictly your core printing press account. It defines the token, like how many decimals it has or who holds the authority to mint more, but it doesn't actually hold any balances itself. It just generates your specific token. And that brings us to the storage side of the equation, the Associated Token Account, or ATA for short. Think of the ATA as a highly specific, deterministic storage vault. It's designed for one specific token type and one specific user. Every single time you want to hand out the tokens your printing press just made, you have to place them neatly into the recipient's dedicated ATA. Honestly, if there's no ATA, there's no token transfer. It's really that simple. Finally, we have our Metaplex PDA. Now, PDA stands for Program-Derived Address, and you can think of it as the unforgeable certificate of authenticity for your token. See, the SPL Mint is basically just raw numbers. It doesn't know its own name. So this PDA mathematically binds all that rich metadata we mapped out previously, things like the name, the symbol, the creator royalties, directly to your SPL Mint. The PDA is essentially what gives your token its soul. Okay, Section 3. Assembling the SPL Mint CLI Quick Steps. It is time to execute our plans and actually construct this token press using the Solana command line interface. And you know what? The assembly line is beautifully simple. First, we just point our tools over to Devnet. Second, we create the token mint with our planned decimals. Third, we construct that ATA vault for ourselves. And finally, step 4, we fire up the machine and actually mint the tokens. And here is the best part. Because we are operating safely in the sandbox of Devnet, we can easily run that mint command with a nice, huge number. Let's go with 1 million. Boom! You are instantly a millionaire. Okay, sure, you're a millionaire of your own completely worthless test token, but come on, it still feels pretty good to see that balance, right? Enjoy that Devnet wealth while it lasts. Let's move to Section 4, Scaffolding Metaplex Metadata, Attaching the Schema. So with our basic SPL factory humming along and pumping out our newly minted millions, we need to attach that rich metadata schema we designed back in Lesson 3. To do this reliably, we use a TypeScript script that interacts directly with the Metaplex metadata program ID. And yes, it is that massive, intimidating string starting with meta and ending in x1s. Trust me, you are going to get very used to seeing this exact string. Our script uses this ID to deterministically find the correct PDA so we can store our data on-chain. The really crucial part here is what we actually feed into that script. We take our metadata blueprint data. So that's our name, our symbol, a valid metadata URI that points to our off-chain JSON, our seller fee basis points, which by the way is just a fancy, overly technical way of saying royalties, and finally our creators array. Our script injects these exact variables straight into the Metaplex PDA. It's literally stamping our token with its unique identity and rules permanently onto the blockchain. Almost there. Section 5. Devnet verification checkpoints, the factory inspection. All right, the machines are off, the digital dust has settled, but now comes the most important phase of any build. It's that moment of mild panic every developer faces after running a script where you ask, okay, but did it actually work? Before we celebrate our successful migration to the SVM, we cannot just assume everything went perfectly. We have to rigorously verify that our DevNet artifacts match our acceptance criteria. To do this, we have 4 very strict criteria on our inspection checklist. First up, does the SPL mint exist? We check for JSON showing the correct decimals and supply. Second, does minting actually work? We need to see a confirmed transaction hash and an updated ATA balance to prove it. Third, is the Metaplex scaffold intact? We check the account for a matching URI and creators. And fourth, does a test transfer work? We want to see that a recipient's ATA balance actually went up. We programmatically check these 4 things against the blockchain to be absolutely certain we are fully operational. Which brings us to Section 6, wrapping up the build, gathering deliverables. Once your inspection passes all those checks with flying colors, it's time to pack up your artifacts for the final capstone project phase. You absolutely must securely record these exact deliverables. You're going to need your mint address string, your metadata PDA address, the minting transaction hash, the transfer transaction hash, and your mapping alignment notes. Keep these extremely safe. These are not just random text strings. They are the hard proof that your abstract EVM designs are now fully alive and functional on Solana. If you remember absolutely nothing else from today's build, let it be these 3 core principles for transitioning over to the SVM. Number 1, keep your design and code aligned. Number 2, treat metadata as an auditable artifact. And number 3, always automate your verification. Honestly, that right there is the daily mantra of a successful Solana developer. So, we finally arrive at the big question. Your artifacts have survived the cozy safety of DevNet, but what happens when your code meets the unforgiving, high-stakes chaos of mainnet? Are you truly ready for a production-hardened deployment? Make sure to visit forge.college to dive much deeper into this curriculum, review all your test scripts, and prepare for that final leap. Thanks for learning with me today on this explainer brought to you by Forge College. Now get back out there and keep building.